Hi everyone. So I'm Andrew. I work for a company called Shearwater GeoServices, and we've recently moved one of our data centers to Iceland. We've migrated here from the UK, or we're still in progress in doing so. So I thought I would just share some details of that journey and perhaps quantify some of the cost and CO2 savings that we've had. Who's Shearwater? Well, we are a marine geophysical services company, so we have a number of vessels. We do marine acquisition and processing and imaging services essentially, and as part of that we offer our own software, and we have a big R&D offering. So we like to call ourselves kind of sensor to image, so we will be a company, we acquire the data using our own technology, our own sensors, and we'll take that data and process it to a final usable image for our clients around the world. And that will be in the oil and gas sector, as well as renewables, wind farms, CCUS, etc. So we're seeing that as a big emerging part of our business as we migrate away from fossil fuels and in towards the renewable space. So we've got our headquarters are actually in Norway, but our main operations is in the UK. And then we obviously have these kind of vessels around the world which are acquiring data all the time, and we're using that data. This one's a really nice slide because it can kind of tell us the whole story about what we do. So on the top here, you have a carbon capture and storage, undersea storage reservoir that we might be imaging. We've got the vessel towing some streamers, some seismic streamers. We're gathering data there. You can also see some ocean bottom nodes, which is another data acquisition technique we use. But essentially, all this raw data gets collected, sent to our processing house, and in that processing house, we then basically will create an image. And these images you can see on the left-hand side, bottom left and bottom right. And on the bottom left, you can see we're imaging a reservoir. We're looking at something which is called full waveform inversion. So essentially, we're creating a model of the subsurface and fitting and using an inversion technique, which requires quite a significant amount of compute to image and create a velocity model of the subsurface. And this is basically the equivalent velocity model here, and this is on our software package. But that can take maybe from acquisition to this image, it maybe takes a year to get something like that. And so what we're looking for doing is to reduce that cycle time, reduce the amount of emissions associated with it, and kind of just make things just generally a bit faster. And part of that, Iceland comes into that solution because we can use bigger compute for less money. We don't have to go to cloud as a solution either. But essentially what we're looking at is we're going to basically 84%, by March next year, we'll 84% cost saving versus our UK data center. In terms of cost, by March, it's about $173,000 a month, or pounds a month, sorry, that we'll be saving. It's crazy. So it's big numbers. And we tend to run, we operate our data centers or our compute hot, and we've got this burst model. The burst model only works if we use super high utilization of the resources that we own. Otherwise, we're just wasting resources. So moving those resources that we're going to run hot to a nice, stable cost environment where we can see long-term pricing, we can see like renewable, sustainable sources of electricity, it really makes a big business case for us, and it also aligns with our corporate and strategic goals in the environmental space. So yeah, so it's quite nice. It's quite a nice slide, and it tells a story of anybody who wants to move anything to Iceland. If you look at this slide, you realize actually it's a good idea.